So hi everyone. So from today's video, we are going to start a new topic that is called sliding window. And always remember, sliding window has a two topics like fixed size or variable size. We will come eventually variable sized. So from today, we are going to start fixed size, and specifically we are going to do maximum sub array of size k. Problem link is there. So let me click this and we are going to solve this today. So let's start. So we are going to start a sliding then window, specifically fixed size. Fixed size is very easy as compared to variable size. Variable size is also easy, but you have to understand. But fixed size is very easy. So let me take an array. Let's say A, B, C, D, E, F. This is the array is given, and this A, B, C, D is representing the element. Okay. Now another thing is given like k equal to 3. This is the length we have given, and remember two things like what is the length which is given 3, and second thing is contiguous. Contiguous means let's say you have to take three elements but in a contiguous fashion. How? Let's say if you take first element A, and you must have to take B and C. These three are contiguous. So A, B, and C is contiguous. Okay. Now, if you try to take A and then you take C and then D, is this contiguous? Sorry, A, C, and D. Is this contiguous? No. Why? Because after taking A, you have to pick the element B. You have to pick this one, because you can say you have to pick the adjacent element. If you are starting from a D, then you have to take its next element to complete the length. Okay, so I have to take three elements. So if I'll start with D, this one, then I have to pick E also and F also to make the length of 3. So it will be D, E, and F. So this is the contiguous subarray. Remember one more thing, sorry, that is subarray. Subarray is also like you can't skip the uh, in between elements. Like let me show you. Contiguous or I think subarray are similar. I don't know, but it's very similar. Subarray means you can take this one as a starting point, as a starting element, then you have to take its next, then you next, then the next, like this and so on. If the length is 3, then you have to pick these three elements if you are starting from this. So contiguous and subarray I think are the similar, kind of similar, I don't know. Okay, so if you start with D, then subarray means you have to take the next element, you have to take the next element, and so on. Contiguous means also same, and if the restriction was there, length is there, so you have to pick these three elements. And if the length is k equal to 2, then if you are starting from a D, then you will pick only these two. So I hope these three jargons you understood very deeply, carefully. So okay, only these things are important. Now, just one more thing, and you will be able to solve all the problem fixed size of sliding window. Let's say you have a k equal to 3, and you have to take all the subarrays. How many subarrays you can form of length 3, which is contiguous? Okay, so let's start with this one. Okay, uh, we can take this and this. Only this thing is possible, A, B, and C. And if you start from this, how many subarrays are possible starting from A of length 3? there is only one. Remember remember one thing from here, from this concept, like if you are starting from any element like a, b, c, if you are starting from any element, there is going to be only one. If happen, if there is subarray of length 3, there is only one. Let me show you. So I already show you for element A. Now if you start from B, you can take this and this. So your array will be, subarray will be C and D, B, C, D. Now if you try to pick another subarray of length 3, I know you can pick A, C, D and E, but you have restricted with the length. You can't take less elements like 2 elements. You can't pick higher elements like k is greater than 3, like 4 elements. So you have to take 3 elements, and it is starting from B and C, D. You can't do this. Okay. Now if you start with a C, there is only one subarray form of length 3. So C, D and D. Okay. Now if you start from D, uh, E and F. So one more D, E and F. Okay. Now if you start with E, E and F, and as you can see, we have to choose of size K, of size K, that means 3, and there is only 2 elements, so we can't take this subarray. So let's just erase. And from this array you will able to form only 4 subarrays of size k, which is contiguous. So remember one thing, this is the thing, you like this, then this and this. You have to observe, you are increasing, like first of all this is the starting, like this is the 3 element, then you move one ahead and you remove one element from the current whatever you have, like okay, let's just take a question and we will solve eventually. I think I have explained all the jargons you have to understand. Now let's take a question and you will be able to solve, I think, most of the problems. So let's take, given an array of integer and a number k, return the maximum sum of subarrays of size k. A subarray is contiguous. Okay, now I already told you, like a subarray is equal to the contiguousness. Okay, so let's say we have given array. Let's take an example: 100, 200, 300 and 400. 100, 200, 300 and 400. So this is the array we have given, and we have to find, what is we have to find, let me write it over here. So we have to find maximum sum. So let me erase. Okay, maximum sum. What we have to find? Maximum sum. And we also have a size constraint, it is equal to 2. So we have to find the subarray of size 2. uh, all the subarrays, uh, do sum of them and take the maximum of them. Let's just create all the subarrays. How many subarrays we will form from this array? So let's see, of size 2. So this is the subarray we can form: 100 and 200, starting with 100. Now if you move, this is the current, and if you move one and add this thing and remove this one and add this one, then you will get a new subarray that will be 200 and 300 included. So 200 and 300. Okay, now this is your current window, we will call it window. Okay, now if you move one more, then you will lose this thing and you will able to add this element. So how it looks like this thing. Okay, so we have array is like 300 and 400. Okay, we have included all the subarrays of size k, of size 2. Now if you sum this, like this is 300 and this is 500 and this is 700, and if you take maximum of this, you will get 700. So answer would be 700. Yeah, it is 700. So you have to create a window of size k initially. So let's take one more example so that you can understood better. Let's take 100, 200, 300, 400. Okay, 100, 200, 300, and 400. Uh, okay, let's take 500 as well, or k equal to 3. So we have to select the subarray whose size is 3. So initially what I will do is I will add all of this 3, add this 3. So we will get 100 plus 200 plus 300. You will get what you will get: 100, 200, 300, 300, 300, 600. You will get 600. Now if you find the next window, like your window is here, let me mark with green color. This is your window. Okay, now if you find the next window, next subarray whose size k equal to 3, then you will have to move one step ahead so that this will be included, and whatever the first element is, we will discard this. So if you have this sum, like uh, this is the sum is 600, and you just move ahead, so 400 is included. That means 600 plus 400, what will be that? It's 1000. Okay, 1000. Now this 1000 represents this whole thing. Okay, you want this window sum, this window sum. So how we will achieve it? Like you have to minus 100. So 1000 minus 100, what will be? This will be 900. So you will get this sum which we want. So one window has some 600, another window has a some 800, 900. Let's take one more. Okay, now our window is this. Let me mark it with yellow color. Our window is this, which has a sum is 900. This is the 900. Now if you move, if you find the next subarray, uh, it will be this one. How you will get it? Like this is the yellow color we want. So as you can see, this is 900, this is 900, yellow color is representing 900. Now if you move 900, then you have to add this. So 900 plus 500 equal to 1400, and you have to subtract this. Okay, so it will be 200 minus 200, and oh sorry, it will be 1200. So the yellow, this is the blue thing, this is the thing, this has a sum of 1200. So this how this is work? So let's code it so that you can better understand. So we have given an array. Okay, fixed size. So first of all, what we will do, so first of all, let me create a sum. Let's just create an answer. Int answer. Answer is going to be 0. Okay, we have to find the maximum, so we will start with a 0. initially marked answer with a 0. Now we will create a int current sum. First of all, we will create a window. So let me write it. Create a window. Okay. Now int I equal to 0. I is less than k I plus plus. Okay. What we will do? Current sum plus or equal to array of I. So what I have done, let me take an example. One second. Okay. So 100, 200, 300 and 400. So and the length is given as 3. So we are creating the window. So window is like this. This is the first window. So let me do indexing 0, 1, 2 and 3. Okay. So k equal to 3, so we will go until k is less than 3. Sorry, this is not 3. Yes, k is less than 3. So 0, 1, 2 will go and sum all this uh, uh, index element. So you will get what you will get 100, 200 and 300 will be 600. So you'll get 600 in a current sum. So we will update with this max of answer and current sum. Okay. Mm. Okay. Now what we will do, we have this window. Now if you want to move to the next window, that means this. So we will start from k plus 1. Sorry, k, only k. Let me erase. We will start from k. K is the index, so we will start from here and we will minus the thing. We will plus this thing. Let me show you. 600, we have current. This is representing current sum plus what we will do, plus it will be array of k, and we will remove this thing, array of what will be k minus, sorry, I minus k. So what is the I? I is 3 and k is 3. So I will increase 4, then k is remain the same. So 4 minus 3, it will eventually come. So we will start from, okay, 4 and I equal to k, I is less than n, I plus plus, if, oh sorry, answer equal to max of answer, uh, max of answer or current sum. We will do every time, and current sum will be um, array of k, sorry, I plus array of I minus k plus current sum itself. So rather than naming it current sum, we will say window sum. We will copy this and paste it over everywhere where written current sum. Sorry, is paste. Okay. Now at the last we will return answer. Okay, let's compile and run. Not the current sum. Paste. Okay, we are getting a compiler error. What it says, int I equal to k, I is less than n is not declared, so we will declare n equal to array dot size. I hope now it will run. Okay, it is expected is okay. Your output is 1. 100, 1300, and expected would be 700. uh, okay, size equal to 2. Is there, we have mistaken. Okay, let's do dry run. We'll see. 100, 200, 300, and 400. 300 and 400. Then if you do the k is given to us is 2. Now initially window sizes, let me mark 1, 2, and 3. Okay, now if you have to do 0 and 1, so you'll go to 0 and 1. So I is less than 2. 0 and 1 is possible. Then we will start from 2. To add this, we'll remove I minus k. I is what? 2 minus k. K is what? K is 2. 2 minus 2 is 0. We will remove. Okay, so we have to remove this. I have add this. Okay, let me compile and run. Now it will run and give expected answer. So let me submit this and see if it is correct or not. Okay, problem solved successfully. So this is the concept, and we'll do the next uh, 2 3 problems, and this is very similar to the first one. And if you understand those things which I told you in this video, you will like the all the other problems are very similar to this. So let's, if you like this video, please share this and subscribe this channel. We will meet in the next video. Thank you.